progress report for ChomskyLovesDL. We start our discussion with the pre-processing steps needed for question generation. The first step is scraping. So if the Wikipedia articles are in JSON format, we plan to use Beautiful Soup library to extract the text present inside tags such as H and P. Then we have tokenization using NLTK. Then we have stop word removal again using NLTK. Then we have pronoun transformation and coreference resolution, which will be explained further. And then we have parsing using Stanford's NLP parser. Our approach is to have multiple independent modules for generating questions of different types. Then we want to use a single question ranking system for selecting top questions. For the question generation, we tried to split the corpus into topic description pairs. We then select our topic and generate questions from its description. The Wikipedia corpus consists of topics and corresponding descriptions, and we could construct pairs from it to generate more specific questions. For this process, the set of adjectives is predefined so far, but could be augmented by extracting additional adjectives or pieces of description from the source. First, we tried to specify templates for generating queries. So here we have certain examples of a house question and a yes/no question. We will explain how to use them in a moment. So we found that it is often the case that sentences use pronouns to refer to entities from previous sentences in the corpus. Hence we perform coreference resolution. In this example, without coreference resolution, we would only be able to ask questions about the sentence where Tom is explicitly mentioned. Whereas if we resolve the he to Tom, we can also ask the question, how old is Tom? To generate questions with this sentence, we need to decipher what the main entities in the question are and what its attributes are. To do this, we perform dependency parsing. When we identify Tom and cat, we can ask the question, is Tom a cat, for example. By generating a relational map as seen in the slide, we can manipulate the order of words in the sentence based on the parts of speech to produce questions. So now we can use the parse tree to generate questions, and we will explain these examples in a moment. In the future, we want to subcategorize questions based on the parts of speech that can be used to generate them. We move on to our first category of questions, which is binary questions, which have an answer in the form of yes or no. So our first approach to generate binary questions is as follows. We extract A, which is a topic sampled from corpus, and B, which is the title of the Wikipedia page, along with adjectives which could either be predefined or taken from the source. So an example of this would be B equal to the title, the NFL season 2009, and a subsection called public response, which is going to be equal to A. We are going to use the template was the A of B adjective followed by a question mark, and the question which would be generated is, was the public response of NFL season 2009 good? Our second approach is the naive way to solve this problem. We find instances where a noun phrase is followed by an auxiliary verb. Then we swap their positions and replace full stop with a question mark. So here in this example, you can see CMU is a big university. Here the noun phrase is CMU and is an auxiliary verb. So we swap it and we get, is CMU a big university? We replace the full stop with a question mark. We move on to our next set of questions, which are compound questions. To tackle them, we find the auxiliary verb corresponding to the main verb and position it at the front. Then we convert main verb to its root form. So for example, we have the sentence and we add an auxiliary verb, which is does. We convert the main verb to its root form and add a question mark. The second example works the same way. Next, we add some variety to our questions which are being generated by doing word transformations using semantic relations via WordNet. So the approach could be to identify adjectives and transform it to its synonyms or antonyms, and based on that we can change the answer to the question. So an example is, John is a kind person. we generate the binary question, is John a kind person? And now we can transform the adjective to benevolent, and since it's a synonym, the answer remains the same. In case it is not a synonym, the answer changes. Next, we talk about how to generate how questions. We use the same approach as we used in the binary questions using the key description pairs. So we extract A, which is the topic generated from the corpus, and B, which is the title of the Wikipedia page. Then we use the template how was the A of B. So an example could be how was the public response of NFL season 2009. Our next kind of questions are what or who questions. So to tackle this, we first find the nouns in the sentence. If the nouns are labeled as N and P, we determine whether it is an object or a person's name. So if it is a person's name, we will replace it by who, and if it is an object's name, we will replace it by what. So for example, we have Ram is a boy and Ram sleeps at night. Now we find that this is a noun which refers to a person's name, we replace it by who. But if it is not a noun which refers to a person's name, we replace it by what. We can also tackle who or what questions using another approach. So we can use the template what was A in B, or what was A of B. An example is the question what was the public response of NFL season 2009. Next we talk about how to generate why questions. So to do that, we need instances of subordinating conjunctions, which are words such as because, since, so, due to, etc. So we convert the phrase which occurs before these conjunctions into the question, and the phrase which will follow them would form the answer. So for example, you have the sentence Roger went to the university because he wanted to be a good doctor. Now this part will form the answer and this part will form the question. To convert this part into a valid question, we first convert it into a binary question. So it becomes did Roger go to the university, and then we prefix why. So it becomes why did Roger go to the university. Next we determine how we will rank these questions. So the first criteria is syntax correctness. So we will give higher scores to questions with the correct syntax and eliminate questions with completely incorrect syntax. The second is number of words. So our intuition is that if a question is too big or too small, it is probably not a very good question. The third criteria is how frequent a particular question category is. So our intuition is to prioritize questions from a category which has less number of overall questions. So for example, if we form 50 questions from the binary question category but only 3 from the how question category, then we imagine that those 3 how questions would be more profound. Next we move on to our answering phase. So the first approach is for generating binary answers in the form of yes or no. So for this specific task, our first approach is to model the corpus as a bag of words model and perform common pre-processing tasks such as stop word removal, stemming, etc. And then we find the most similar or relevant sentence in the corpus with respect to the question. So to do this, we will treat the question as a query and do query expansion to match additional sentences which may not have the same exact words. So here are the details of how we perform query expansion. First we add synonyms, antonyms and other semantically related words such as hypernames, hyponyms, etc. to the query. Then we add all morphological forms of the query words by stemming each word in the query. And then we fix spelling errors by matching the closest correct word using Levenstein distance. Then we match the expanded set of queries using cosine similarity, let's say, and retrieve the most similar sentence to the given question. Our approach for binary question answering is as follows. We will give the default answer as 1 after matching the sentence, except for the following cases. So case 1 is if we detect negation in either the query or the sentence and the number of negation words are unequal. So for example, we have the query of did Johnny go to the school and the match sentence contains a negation word, so the answer would change to no. In the same way, if we have a change in proper noun, such as in this sentence, the noun California is changed to Pittsburgh, and hence the answer is again no. Third case is when there's a change in the common noun such that it is not a hypernym or a synonym. So let's say the original sentence was Rosie gave Ronnie a rose, and the question generated change rose to flower. In this case, it's a hypernym, therefore the answer remains yes. If we have a sentence where the object is completely changed from rose to car, then we would answer no. The fourth case is when there is an antonym in the query and sentence. For example, if the original sentence was Mary loves to drive and the question generated changed loves to hate, the answer would be no because these two are antonyms. So that's it for now. Looking forward, we want to generate answers from the parse tree using the following broad steps. We want to split the document into sentences, perform coreference resolution, generate certain facts using dependency parsing, then filter sentences by entity and consider attributes to match questions with answers, and then do evaluation. Thank you.